so much excited. How can you measure excitement? Somebody is saying he's finding it difficult to join the group. I'm coming. Somebody is complaining of that difficulty in joining. It's the same ID we used yesterday.
Can I have?
Please, when you join, mute yourself, okay? When you join, mute yourself.
Oh.
Charity Mesa. Charity. I think I need to control everybody instead. Okay, so as I was saying, non-physical quantity you cannot measure. An example of it is happiness, joy, angry. These emotional stuffs you cannot measure. You cannot measure. So that is it. Then the next question is asking of show how the unit of force into bracket Newton is derived from base unit. Okay, so we did that yesterday. Okay, we determined the base unit and then concluded that these base units are unit. So instead of the base unit, it is changed to names of some famous scientists. Okay, but the actual units are the base unit. An example, we spoke about the Newton, watts, joule, Pascal, ampere, and so on and so forth. So if you are to show this, you use dimensional analysis to derive the base unit of force and then express it in the SI unit. Explain derived units with calculations. Show how the unit of force is derived from the base units. Calculate. So we did, this is in line with how, okay, what we did yesterday. The Newton was derived from the base quantity. So show how we can use this to derive the unit of force. And then calculate weight of 5 kilogram mass on Earth when G is 9.8. And on the moon, G is 1. So calculate the weight of a 5 kilogram mass on Earth and on the moon. So simple. Weight is mg. You have the mass, you have acceleration due to gravity. So on both moon and then the Earth. Okay. So I don't think we need to waste our time on this particular question, because once we know weight is equal to mg, then it implies that if you are looking for the weight on moon and weight on Earth, you have W being equal to mass of the body and then acceleration due to gravity on Earth, and then mass of the body and acceleration due to gravity on moon. Mass is constant. Mass does not vary from one planet to another. Class, are you with me?
Yes, sir.
All right. Then question 2, explain dimensional analysis and its uses. We did that yesterday. and then check the dimensional consistency of V squared. V squared is equal to U squared plus 2AS. Dimensional consistency implies that you have to check the validity or the correctness of this equation. So, come again.
Please, a question.
All right.
So please, the number 2, they didn't give us what the V was equal to, what the U was equal to, what the A and the S.
So they should have defined it.
Yes, please.
Okay, it should have been defined where V and U are velocities, and then A acceleration as they should have defined each and every formula. So we are to check the dimensional consistency or validity of this equation. Determine whether equation is correct or consistent. And in checking the validity of an equation, if an equation is correct, then the left-hand side must be equal to the right-hand side. I hope you know this.
Yes, sir.
Let's then substitute the dimension of each side. At the left-hand side, we have V squared. V is velocity, U is also velocity. So we have, what's the dimension of velocity, class? Quick one.
LT neg 1.
So LT exponent -1 squared. This must be equal to, U is also velocity. So LT neg 1 exponent -1 squared plus 2. What's the dimension of acceleration?
LT raised to the power -2.
So LT raised to the power -2 times dimension of displacement L. So we need to simplify the right-hand side. Vincent, mute yourself, okay? I'm getting a feedback here. All right, so we have L squared T exponent -2 plus 2L squared, L times L, T exponent -2. Okay, we have equal terms. So this, the right-hand side is similar to where you have A plus 2A. A plus 2A is equal to what?
3A.
3A. So this is 3L squared T exponent -2. This is also equal to, the left-hand side is L squared T exponent -2. The numbers are non-dimensional constant. Okay, so we can ignore it because they don't have dimension. But once this dimension here is equal to what is here, then we conclude that the equation is therefore consistent or valid. So this is how we can use dimensions to test the validity of this given equation. Please, is that understood by all?
Yes, sir.
Yes, please.
All right, so let's look at the other question. T is equal to 2 pi. Yes, as you said, they should have defined the letters. Where T is this. So because T, you can mistaking T for temperature. T is equal to 2 pi times L over G. You have to use dimension analysis to test if this is valid. Here, this T is period, stands for period. A period is a time, a specific time taken to make one complete cycle. L here is length, and G here is acceleration due to gravity. So if T is time, a dimension would be capital T. So it means that the left-hand side must be equal to the right-hand side. 2 pi is a constant, non-dimensional constant. So we can even overlook it. So we have square root of L is length, the dimension capital L, divided by acceleration due to gravity is acceleration. And the dimension of acceleration, LT to the power -2. Class, are you with me?
Yes, sir.
So it means that we must simplify the right-hand side to be equal to this. Okay. L would cancel L. So we have 1 over T to the power -2. You know that if I can express 1 as T raised to the power 0.
Yes, please.
Any number raised to the power 0 apart from 0 itself is equal to 1. Okay. So we have square root of T raised to the power 0 over T this. And so we can use indices to simplify this to have T. If you have two numbers dividing one another and they have the same base, subtract the denominator base from the numerator base. So 0 minus -2. So we have square root of T raised to the power 2, isn't it?
Yes, sir.
Okay, and what is square root of T squared?
It's T.
T. So if you don't understand, you can quickly change the search to indices. Square roots is the same in indices, is raised to the power half. So this 2 would cancel this. And so we've managed to have the left-hand side being equal to the right-hand side, isn't it?
Yes, sir.
And so the equation is dimensionally correct or valid. Is there any question?
Yes, sir.
All right. Gerald, are you following? Charity, or why Henen,
Yes, sir.
Jonas, Fosti, Cromwell? If you have any question, quickly ask. So the difficulty with this question is that they should have defined the letters. If you don't define it, you will actually be at C. And I'm sure you were at C. Some of you were at C.
Yes, sir.
Especially if you have not solved the question before. Okay, the next question is that we have F is equal to mv squared over r. We solved this question yesterday. Here, F is a force. This is the formula for centripetal force. Centripetal force. So F is a force. M is mass. V is velocity. R is radius. R is radius, and radius is a distance or length. So I want you to quickly try this. Test if this equation is valid. Try this. Within 5 minutes, you must finish. That's okay.
Yes, sir.
So let's test the validity of this equation. And it must be valid. The expected result is that it must be valid.
Very deep.
It must be valid. Meaning the left-hand side must be equal to the right-hand side. So is it valid?
Yes, please.
Okay. So some few minutes so we can discuss. As I said, you must have a valid answer. Meaning the left-hand side must be equal to the right-hand side. All right. So if F is a force, the dimension of force, yes, class, what's the dimension of force?
MLT.
LT exponent -2 must be equal to M, then velocity LT exponent -1, this must be squared, divided by L. Okay, so we have M, L squared, T to the power -2 divided by L. So L will eliminate, the denominator L will eliminate another one. So we have M, L raised to the power 1 t raised to the power negative 2. And we have the left-hand side being equal to the right-hand side. So the equation is dimensionally correct or consistent. Please, did you all get the same answer?
Yes, sir.
Yes, sir.
Okay. Question B. Use dimensional analysis to derive a formula. The period capital T of a simple pendulum may depend on the length, mass, and gravitational acceleration G. Using dimensional analysis, using dimension, derive the correct relation. So we are asked to derive this equation. Okay, but we are told that the period capital T depends on the length, so L. It also depends on the mass, M, and gravitational acceleration, G. So we are to use this equation to derive this. So let's see. So if T is equal to K L exponent X, we don't know the exponential power, M exponent Y, and G exponent Z. Okay, then we substitute dimensions. Dimension of length, L, X. Dimension of mass, M. Dimension of acceleration due to gravity, L, T exponent negative 2. Let's raise to the power Z. So L exponent X plus, okay, let me do it systematically so that you can all follow it well. So we expand whatever we have within the bracket, L exponent Z, T exponent negative 2Z. Are we following?
Yes, sir.
Then we group like terms. We group like terms. L X plus Z times M exponent Y and T exponent negative 2Z. Okay. The next part is that we input the dimension of the left-hand side. T is period, and period is a time. Dimension of time, capital T. So we equate T exponent 1 to T exponent negative 2Z. So we conclude that negative 2Z is equal to 1. Therefore, Z is equal to minus half. Are we okay here?
Yes, sir.
Then L to the power X plus Z has no component at the left-hand side. So it's like, it's 1 here. So we can, because we can represent any number 1 by L to the power 0. Okay, we equate L exponent X plus Z to L to the power 0, meaning it's 1. When it's 1 here, it doesn't change anything. And so we conclude that then X plus Z is equal to 0. X, therefore, is equal to negative Z. And once we found Z, we can easily find X. So Z is negative half. So negative times negative. So we have
Positive.
X being equal to positive half. Are we okay with this? Class, are we okay here?
Yeah, I don't understand that part.
You see, L exponent x plus z at the right hand side has no L component at the left hand side. Are we okay?
Yes, sir.
So it is like this is equal to 1 here. Okay,
Yes.
so because we are equating left hand side letter to right hand side letter, I'm trying to create L component at the left hand side as well. That is why I equated L exponent x plus z to L exponent 0. Because L exponent 0 is 1, and 1 times any number doesn't change the number. So it will still give me t at the left hand side. That is why, but to be able to compare the exponential powers, that is why I inputted L exponent 0. Are you okay?
Yes, sir.
Just to help you see that, then x plus z would also be equal to 0 for us to find the unknown variable. And that's the same thing we'll be doing to m. M exponent y, we don't have any m component at the left hand side. So we'll equate this to m exponent 0. Because if we bring m exponent 0, it doesn't change this t. The value is still the same. Are you okay? So straight away, we conclude that then y is 0. If y is 0, we have z, we have x, we have y. Let's substitute it into this equation. So we have t is equal to k L exponent x, and x is half. M exponent y, and y is 0. J exponent z, and z is negative half. Okay.
Yes,
So
sir.
t therefore would be equal to, let me use the same page so that we can follow. T is equal to k L exponent half. M exponent 0 is 1. We won't disturb ourselves. But g exponent negative half is equal to 1 over j exponent positive half. This is coming from, if I have a exponent minus n, this is the same as 1 over a exponent positive n. The reason is that in indices, I can also decide to write 1 as a exponent 0, so that both the numerator and then the denominator can have the same base. So I can subtract this denominator exponent from the numerator, 0 minus n, and it brings me back to a exponent negative n. All right. So it's just application of indices. So if g exponent negative half is the same as 1 over j exponent positive half, then I can represent this as t equals k L exponent half times 1 over j exponent positive half. And if you have two numbers with the same exponent, if I have a exponent, maybe m, over b exponent m, then I can bring both numbers and under the same exponent. So this is the same as this. A over b, all exponent m. Please, are we following the rules?
Yes, sir.
Yes.
This means that I can bring L and J, okay, under the same umbrella and raise them to the power half. So T is equal to K L over G all raised to the power half. And a number raised to the power half is the same as the square root of the number. So T is therefore equal to K square root of L over G. So we've derived the same equation we were. So here, K, the constant K is 2 pi. Our constant of proportionality here is equal to 2 pi. So if you leave it here, you'll be marked correct.
Okay.
But if you could also understand that, under this equation, the constant of proportionality K is 2 pi, and you put it there, it wouldn't also change anything. Please, is there any question? Is there any question? I'm recording, so I'll later put the video on the page. Okay. A boat sails 8 kilometers east. So that initially it sails 8 kilometers due east. And then 6 kilometers north. Calculate I, the straight line distance from starting point. Calculate I, the straight line distance from starting point. So you have to draw. You have to draw, represent this in a diagram form before you can answer. So let's draw a cardinal point. On the cardinal point, north is here, south is downward. What is this direction? What is this direction? I'm hearing two answers. Is it east or west? That is east. And this is west. The question is saying that it sails 8 kilometers east. So from its starting point, it's starting here. It moved a distance of 8 kilometers due east. So it means the magnitude of the distance or the displacement is from this point to this point. Okay, and then 6 kilometers north. So it's like you embarking on a journey. You started from a point, came to another point, a point O, came to another point A. You didn't end there. From O to A, the distance covered is 8 kilometers. Then you further moved 6 kilometers due north. So from here, okay, what will be our north? Must we go up or down? From A, must we go up or down?
Up.
Obviously, due north, you go up. In drawing this, you must know that the first displacement is larger than the second displacement. So you shouldn't draw a line for the second one to be greater than the, okay. So this is the new location of the body. Let's represent this by X. So it moved from O, came to A, due west, due east. Then from A went due north. Now the question is that calculate the straight line distance from the starting point. What is the current location of the boat? What is the current location of the boat? It is at X. So if I'm asked to calculate a straight line distance from the starting point, what letter represents the starting point?
O.
O, meaning that straight line will be from O to A.
X.
O to X. That's it. Okay. That's it. And this represents OX represents the hypotenuse of a right angle triangle, because AX is perpendicular to OA. And so we can use Pythagoras theorem to find this distance from the starting point. So using Pythagoras theorem, OX squared is equal to OA squared plus AX squared. And OA is 8. So we have 8 squared plus 6 squared. A squared is 64. 6 squared is 36. Okay.
Yes, sir.
Totaling 100. Therefore, OX is equal to the square root of 100. And what's the square root of 100?
10.
10. So it means the distance from the starting point is 10 kilometers. As simple as that. Then calculate the bearing from the starting point. So you are currently located here. Bearing is direction. If I want to quantify the direction from your starting point, it means to locate you from the starting point, I must turn through this angle. Okay, in measuring or in determining angles, there must always be a reference point where measurement is taken from. That is why in your mathematics construction, if you are to measure angle, you put your protractor, the zero line, okay, on the horizontal line. Supposing the point is here, then you read. So from this point to this point, what is the angle? So in measurement of angle, there is always a reference point. And here, our reference point will be along the west-east line. Okay, so if I want to determine this angle, it is equal to the angle between the current location and then the reference point where measurement is taken. Class, are we fine?
Yes, sir.
And we can do that using trig ratios. Which appropriate trig ratio can help us here? Class, which appropriate trig ratio can help us? In this regard, we can use all of them since we have all the sides. We have the opposite to this angle, adjacent, and then the hypotenuse. So whichever trig ratio we use, it must give us the same results, okay?
Okay.
So if we take tan
And theta.
of the angle, we are assuming that let the angle be theta. So tan theta would be opposite, which is 6, over the adjacent, which is 8. And theta would be equal to the tan inverse of this ratio, 6 over 8, which is also the same as 3 over 4. Help me determine the tan inverse of 3 over 4. So shift tan, then you input 3 over 4. Shift tan, then you input 3 over 4. So on your calculator, you press on shift, then tan. Then you input 3 over 4.
36.86.
36.869.
Okay. So approximately, let's approximate it to the nearest angle. Let's approximate our answer to the nearest angle. What will that be? To the nearest,
37.
go 37 degree. I'm doing this because on your protractor, the least angle you can have is 1 degree. You can have point, maybe 36 point, no. That's why I'm running the angle to the nearest that. Are you okay?
Yes, sir.
So it means the bearing is 37 degree from where? 37 degree from where?
From X.
From, we are bearing direction. From the east. So the bearing is 37 degree north of east. There's the bearing. Are you okay? Meaning that if I'm here, if I'm taking my measurement from the east, I must turn through this angle 37 degree due north to locate the new position. So 37 degree northeast. Or I can also take my measurement from the north. If I want to, if the north is my reference point where I'm taking measurement from, it means I can also turn through this angle and face where the body is. What will be this angle if we are taking it from the north? What will be this angle? What will be this angle? The next question is that, class, what is the total angle between north and east? What is the total angle between north and east?
So is it 90 degrees?
It's 90. North is perpendicular to the east. So the whole angle totals 90. So if this is 37, what will be the remaining angle to complement the whole thing? That would be 90 minus 37, isn't it?
53 degrees.
Good. So it can also be 53 degrees east of north. Meaning if I'm at the north, I can also get the bearing of this when I turn through an angle of 53 due east. So the bearing can actually be this or this. So simple. Please, is that okay?
Yes, sir.
So in physics, we'll be doing a lot of these things. and you understand that, oh, it's not so difficult kind of question. Please, if you have any question, quickly ask. If you have any question. All right, B. 100 Newton force is applied at 60 degrees to the horizontal. Calculate I, the horizontal component, vertical component, and the resultant if another 80 Newton force is added. So let's see. You see, whenever you are looking at measurement of angle, this is a force acting at an angle. If there's no angle, then it means the angle, if there's no specific angle given to you, then it means the force is making an angle of 0 with the horizontal. So in measurement of angles, there will, hello? Can you hear me?
Yes, sir.
Okay.
Yes.
In measurements of angle, there must always be a reference point. Where are you taking your angular measurement from? Is it from the east or from the west? Is it from the north or from the south? Okay, so the question clearly said that it makes an angle of 60 to the horizontal. This horizontal is the west east direction, your x-axis. Supposing the question said the force was acting, okay, on the vertical, then you must draw north-south axis. So you must always find out where the angular measurement is taken from. And you can get that from the question, from the horizontal or from the vertical. Clearly the question said from the horizontal, isn't it?
Yes.
So it means the vertical will not be needed. The vertical will not be needed in this case. So let me clear the vertical. Good. So that is the reference point where angular measurement is taken from. So if supposing this is the center, then I must measure my angle from the horizontal. So the 0, if this is a protractor, your 90 will be here and your 0 line of the protractor will be here. Okay, angular measurement in trigonometry, angular measurement is taken anti-clockwise. So we have to measure the angle in an anti-clockwise direction, 60. So if this is my angle of 60, then that is where the force would act. What is the magnitude of this force? The magnitude of this force is 100 Newton. So 100 Newton force acting at an angle of 60 degrees. That is all. Class, is that understood?
Yes, sir.
We are to find the horizontal component and then the vertical component. You see, whenever force acts along the horizontal, you see, when we were kids, or let me give you this one. If you have a toy car or a table or a chair, and you are dragging it along the floor, pushing it, it means by pushing it in that manner, the angle, the force you are applying on the table or chair mixed with the floor is 0. So it means your force is parallel to the floor. And so you, when the angle is 0, the total force will be concentrated along that direction. If you are also lifting it vertically, if you have the table and you are lifting it, okay, within the airspace, it means the angle you make, the force you are applying makes with the vertical is zero. All the force will be concentrated vertically. So once the angle is zero, the total force would concentrate along the horizontal or along the vertical. If the force makes any different angle apart from 0 and 90, the force will be divided into two. So if I'm pushing along this, the total force acting on the floor will be 100 Newton. If I'm lifting the same object, there's the object, up through the air, it means that it is making, the force is making an angle of 90 with the horizontal. The total force of 100 Newton will act along the vertical. It will never be divided or shared. But the moment the force in question is not 0, it's not 90, it's not 180, it's not 270 or 360, and it is in between, the force will be divided into vertical component and then a horizontal component. Plus a minute, I'm coming in.
Okay.
Hello.
Yes, sir.
So
Yes.
the moment you see this force is, we are told, is acting at an angle of 60, meaning because it is 60, the force will be divided into a vertical component and will also be divided into along the horizontal component. So if you, boys, if you tie an object to a rope and you are pulling, you realize that if you are not careful in your pulling, either the object will be going up. When it's going up, it means that the effective force is acting vertically. That is why the object would go up. Is that clear? So the moment the force acting isn't 0 or 360, 90, 180, or 270, it will be divided into two components. Now, what is this component? This is the vertical component of the force. I don't know if you were taking through trigonometry. In trigonometry means measurement of triangle. If you have a right angle triangle, which is this? This is the angle of elevation or angle of inclination. This is the angle of depression. You do that in math. So if I want to, supposing I have the hypotenuse and it is Z, I can use the hypotenuse and this to find the opposite to this angle when the angle in question is theta. Please, are you following?
Yes, sir.
So my angle of elevation is theta. Angle of depression is alpha. If I want to determine the opposite, I can use the trig ratio sine. Sine of an angle means the ratio of the opposite to the what?
Hypotenuse.
To the hypotenuse. So whenever you are looking for opposite, when you have the hypotenuse, use sine. Whenever you are looking for the adjacent, when you have the angle and the hypotenuse, use what? Cosine. So cos theta would also be the adjacent over the hypotenuse. So here we have the hypotenuse, we have the angle, and we are looking for the vertical or the opposite to this angle. This is F vertical. If you are looking for the adjacent, F horizontal. Okay, so I'm looking for FV. FV will be sine of this angle 60, which is equal to FV, meaning the vertical force, divided by the hypotenuse, which is 100. Then I make the vertical force the subject, okay, by cross multiplying. FV, therefore, will be equal to 100 times sine 60. Sine 60 is equal to root 3 on 2, or 0.866. So you have 50 root of 3, or 100 times 0.866, which is 86.6. So that will be the vertical component of this force, 86.6 Newton. Class, are we okay?
Yes, sir.
Let me have responses from the other colleagues. Please, are we all fine? On the other hand, so we found a vertical component. The horizontal component will be FH. So FH obviously will be when you take cos of 60 degrees. Cos 60 is the adjacent FH over the hypotenuse 100. And then when you make FH the subject, FH is 100 times cos 60. Cos 60 is half. So 100 times half is equal to 50. That will also be the horizontal component of the force 100 Newton. So this is 86.6 and this is also 50 Newton. That would be the expected answer. Please, is there any question?
No, sir.
Then Then the III, the resultant force if another 80 Newton horizontal force is added. You see, we have this force which we are told acts at an angle of 60 degrees from the horizontal. So this is the original question. This is 60 degrees, and the magnitude of the force is 100. So we are told that what is the resultant if another horizontal force is added? You see, here we are not given any angle. All that we are told is that 80 Newton force is added to this force. So we have another force of 80 Newton acting along the horizontal. So this is the other second force. Its magnitude is 80 Newton. So we have two forces. This 100 Newton and another force 80 Newton acting at the same time or concurrently. We have to determine the resultant. Are we okay?
Yes.
So how do we determine the resultant when you have two forces acting in this manner? To do this, you resolve these forces into a parallelogram of forces. So you resolve the two forces to create a parallelogram. And how do we do this? You can do that using equal vectors. Vectors or forces are said to be equal no matter where they are if they have certain condition. One, so equal, please write this down. Equal forces or vectors. One must have the same magnitude, have same magnitude. Equal forces have the same direction, have same direction. So it is like creating the twin brother of these two forces, 180. The other twin brother must have the same magnitude. It must also have the same direction. If they have this, then we can say that they are what? Equal. Okay, so how do I create the twin brother? I want to create the twin brother of 80 Newton. Okay, a vector has tail and then a head. So this is the tail of the 100 Newton. Where the magnitude ends is the head. So I'm going to put 80 Newton force on the head of the 100 Newton force. So watch how I'm going to do it. I'm going to change colors so that we can see. Let me use, okay, blue. So the 80 will be placed on the head of the 100. But all that I need to ensure here is that it must have the same magnitude as the 80. So what is the magnitude 10? The magnitude 10 is that, you see, I measured from this point to this point. So the length represents the magnitude of 80. This one, the twin brother must have the same thing. So from here to this point must also be 80. So we have satisfied this first condition. same magnitude. What is the direction of this? This is due, is it east or west? Is this direction east or west? It's due east. And so this one too must have the same direction, due east. Then I can say that this is the equal component of this 80 Newton force. So no matter where they are, if they have the same magnitude and direction, they are equal forces or vectors. I'm going to do same for the 100 Newton. And I'm going to do that, place that on the head of 80. Earlier, I placed 80, the twin of 80 on the head of 100. Okay, and I'm going to do that on the head of 80 as well. Let me change the color. So it must have the same magnitude as the 100. So carefully measure. Meaning that, you see, the magnitude from here to here is 100. Magnitude from this side to this side must also be 100. What is the direction? It is acting at an angle between north and east. And so it must also have the same direction. So this is also 100 Newton. Now, what's something? If you look at it from below, here, up, or above, here, this. The direction of this plus the direction of this, it means that short distance, which can represent the same thing as if this is going here and then this one is coming here. It means the shortest possible distance I can also take is move from here and straight to where the other one is ending. I'm repeating. So if the direction of the force is whether down or up, this is going here, and this one is also going, then it means they are all coming here, isn't it? Isn't it?
Yes, sir.
So the shortest possible distance is that, oh, I can, if I start my journey straight to this side, it will represent the shortest possible distance. And this is the resultant force. This is the resultant force. This is the resultant force. Now, this is a parallelogram. Once it's a parallelogram, I cannot use Pythagoras theorem to solve it. I must use what we call cosine rule. Please, were you taking through the cosine rule and the sine rule?
No, sir.
Yes,
Okay. Some of you. Okay. What does the cosine rule say? If you have any form of triangle, let me draw any form of triangle. This interior angle is theta. This interior angle is alpha. This is beta. Supposing I'm to determine this side, A, B, C. So meaning if I want to determine any of the three sides of the triangle, the cosine rule says that let's find A first. The square of A, meaning the side that is to be determined, the square of the side that is to be determined must be equal to the sum of the squares of the other two sides. So B squared plus C squared minus 2 times the product of these two sides, 2 times BC. times the cosine of the angle opposite to this side that is being determined. We are looking for A, the side A. Which interior angle is opposite to A? We have three interior angles, alpha, theta, and beta. Beta is opposite to the side in question, isn't it?
Yes.
So cos of beta. Let's look for B, the side B. B squared, the same rule. Yes, can somebody help? We are looking for B.
Is equal to A squared plus C squared
A
minus
squared,
2
A squared plus C squared,
minus 2AC
2AC
cos
cos of
alpha.
code. Somebody to help me with C. How do we determine C? Anyone? Cromwell, once your microphone is on, it means you want to try. Cromwell.
Yes. Square root of A, C squared.
So C squared
Equal to B squared plus A squared.
So B squared plus A squared
Plus AB. Or
So open your eyes.
Plus BA. Plus BA. A minus
minus 2 BA cos theta. Good. This is the cosine rule. We can use it to solve any triangle question, whether right angle triangle, isosceles scalene, or equilateral triangle. Okay, so let's see how we can apply it to this. So please mute yourself if you are not answering a question. These two sides, this one and this one, are parallel. Parallel lines have the same slope. When two lines are parallel, they have the same slope. So it means that the angle between them is the same to the horizontal. So if this is 100, this is 100, and they are parallel, then the angle between this 60 must be the same as the angle between this X and this its other counterpart. So if this is 60, this must also be 60. What's the reason? Because these are parallel lines, equal vectors or forces. Class, are we following? Class, are we following?
Yes, sir.
So we are doing this on the grounds that 100 Newton forces are equal forces. And so once they are equal, it means they are parallel. And parallel lines have the same slope. So if the angle between the horizontal and this force is 60, the angle between this as well must also be 60. Plus, if this angle is 60, what do you think will be this angle? Can somebody help? If this is 60, what will be this angle?
120 degrees.
Exactly, 120. 180 minus 60. So we have this angle opposite to the resultant force. So the cosine rule, it means we can apply the cosine rule. F subscript r squared equal to, hey, I want you to help me. We are applying the cosine rule. F r squared must be equal to it means that we are using this triangle O A B C. So we are considering triangle OBC. Triangle OBC. So we are applying this. FR squared must be equal to
OC squared
so OC squared
plus OB
plus
squared.
O. Did
OB
you?
squared
No, OB is actually what I've represented as FR. Okay, let's use the letters.
plus CB squared.
Okay, so let's use the letters to help the understanding. So it means if you are looking for OB squared is equal to
OC squared
OC squared
plus CB squared
plus CB squared
minus
minus
2
hmm,
minus 2OC
2OC, good,
BC
BC
cos
times the cosine of
C
the cosine of
C.
C.
what the
120.
C there has a value 120 degree. We found that angle. All right, thank you so much. So input the values and help me find OB. We have values for OC, CB. So substitute the values, help me determine OB. Just try. Give it a try.
Sir, please, I had Sir.
Hello. Uh-huh.
Sir, please, a minute.
All right. Gerard, I would apply bearings to this, and so we'll discuss it again.
Okay.
I had 24400
You had 2
400.
for OB,
Yes.
24400. Okay, we shall see. More views.
Sir, I had 156.20.
156.20. The last view.
So I had
Let's solve it together.
the 2440. I did not square root.
You
When I
didn't take
said
the square root. Yes. Okay. So what's your final answer now?
20 root 61.
Change that into decimal.
156.20.
So it's here. One of the answers that was given. Okay. Okay, let's go through it. So OB squared is equal to OC is 80. CB 100 minus 2 times 80 times 100 times cos of 120 degree. So 6400 plus 10, the 4 zeros, minus 2 times 80 times 100 is 8,000. Cos 120 is equal to negative half. Half would cancel this half. Negative times negative is positive. Please, are you following?
Yes, sir.
All right, so we have 16400 plus 8,000. What is 16400 plus 8,000?
The 24400.
So 24400.
400.
Good. Therefore, OB is equal to the square root of 24400. And I'm sure it should be 156.2 Newton. Are we okay?
Yes,
Class,
sir.
are we fine?
Yes, sir.
Yes, sir.
So when you add a third force, a second force, the 80 Newton in this manner, this will be the resultant. So the resultant will be 156.2 Newton, approximately 156. Somebody just asked of bearing. So I'll add, what is the direction of this resultant force? So if I am here, okay, all the two forces, 100 Newton, 80 Newton, have a common point here. If I'm here or along the horizontal, the horizontal or the x-axis is here. Let me draw something. This is the x-axis. This is the y-axis. Let me straighten it. So we can assume that this horizontal x is the road. So if I'm walking on the road and you are located here, how much do I turn to face you? So I must turn through this angle. I must turn through this angle in order to face you. And then if I want to come to where you are located, I must turn through this angle, walk by and cover the magnitude to get to you. Okay, so this becomes the bearing. Let's assume this to be the usual theta. Similar to what we solved when we had right angle triangle. So how do I do this? You can find this angle using the same rule. We can use the same cosine rule. Can I clear this part?
Yes, sir.
No, sir.
Okay, so quickly copy, and then when you finish, draw my attention, okay? We'll be doing vectors this section. So don't worry, you have a very good understanding of how to solve some of these questions, okay?
Mhm.
Please, I'm done.
Sir,
Hello,
you can continue.
okay. I don't want to open a new page. I want to use the same page to explain. So you did not do cosine rule, sine rule in school.
Sir, please, for our school, some of the classes we did.
Oh, okay.
Yes, sir. So, listen.
Mhm. So this time around, I'm looking for this angle theta. That's the bearing of the resultant force. Come in. So the bearing can be determined using the same cosine rule. You see, I have there. I'm still using the triangle OBC. This interior angle I don't know, but I have the side. So it means side BC squared. Help me. BC squared would be equal to BC squared will be equal to
OB
the
squared
OB squared
plus OC squared
plus OC squared minus
minus
2OB
OC
OC times the cosine of the angle opposite to BC is theta. That's what you are looking for. Okay. So theta. And we have BC 100. 100 squared is equal to OB is 156. Let's forget about the 0.2 plus OC. OC is also 80 minus 2 times 156 times 80 times cos of theta. What is left is mathematics. 10,000 is equal to, what's the square of 156? What's the square of 156?
2433
2433.
6.
Is that 2433?
6.
6. Then 6400 minus, multiply 2 by 156, then multiply the result by 80. 2 times 156 times 80.
24960.
24960 cos theta. So 10,000 minus, what's the sum of 24336 plus 6400?
The 307
307.
36.
No, I mean sum 24336
Yes,
and
please.
64.
30
736.
36.
36.
736.
Okay. All right. This is equal to negative 24960 cos theta. Okay, so 10,000 minus 30736.
Negative 23, negative 203736.
Okay. I just want to confirm the answers.
Okay.
Okay. So 10,000 minus 3736. This is negative
20736.
736. This is equal to negative 24960 cos theta. And once we are looking for cos theta, we divide through by negative 24960. Negative 24960. Do that for me.
So 54/56. 54/60.
Change that to decimal.
0.83.
0.8308.
7. Okay, yeah,
Okay.
08.
Theta, therefore, is equal to the cos inverse of this, 0.8308. What's the cos inverse of this figure?
The 33.82.
I just want to confirm too.
Okay.
8308. 33, so approximately 34.
Okay.
What it means is that if you are on the x-axis or horizontal, to get the direction of this, is the current. Oh, the other vector is gone. This is the current location of it. So if I want to face the direction and perhaps move towards it, I must turn through an angle of 34 degrees from x. That becomes the bearing. There is another way. There is another way to do the same thing using the sine rule. So let's use the sine rule just to confirm our answer, okay? Vectors will be doing this, and you understand. We would revisit the same thing again during vectors, so you don't worry. The sine rule says that if you have any triangle, interior angle theta, alpha, beta. This side is A, this side is B, this side is C. It means that if you take a ratio of the side, a ratio of the side to the sine of the angle opposite to it. So let me read your messages too. No, Charity, the cosine is a formula. The cosine rule is a formula, okay? As I said, we'll go back to it again, don't worry. In vectors, we'll be doing the same thing. We are just applying it to solve the question which was brought to us, but we'll revisit vectors and everything, we'll start everything. Okay. So the ratio of the side, if I take A and divide it by sine of the angle opposite to that side, and the angle opposite, hello, please pay attention. The angle opposite to A is beta, so sine beta must be equal to, if I take B divided by the sine of the angle opposite to it, sine alpha. This is also equal to C divided by the sine of the angle opposite to it. This is the sine rule. So depending on the available information, you can pick any ratio. I'm looking for this angle theta. The side opposite to this angle is known. So BC over sine theta, meaning I don't know this, must be equal to, here I have this angle, so I can pick the ratio of this side to sine of this angle. So OB over sine of the angle opposite to OB, which is 120. BC is 100 over sine theta. This is equal to OB. OB is 156.2 sine of 120. Class, quickly help me find sine theta. So we have 100 over sine theta is equal to 156.2 over sine 120. Sine 120 is the same as sine 60. And sine 60 is equal to 0.866. So let's cross multiply and find sine theta. When you cross multiply, we have sine theta times 156.2 is equal to 100 times 0.8660. So please do this for me and help me find sine theta. Class, are you okay?
Yes, please.
Help me find sine theta.
So sine theta is 506.27.
So let's see. Sine theta times 156.2 is equal to 86.6. So sine theta will be equal to 86.6 divided by 156.2, isn't it?
Yes, sir.
And what is 86.6 divided by that? What is 86.6 divided by 156?
0.55. 0.55.
0.55. That's sine. Okay, theta therefore is the sine inverse of 0.55, right?
Yes, sir.
What's the sine inverse of 0.55?
33.36.
So approximately 34, the same answer as we had, right? So
Yes.
that is the direction. So class, yes, as I said earlier, today we are using it to solve problems. This semester or this vacation, we'll treat vectors, and so we'll look at it very well, where you have the opportunity to have a better understanding of it. Okay.
Okay.
All right. So it will be done. It will be done. So by next week, we'll start the main topics. Some schools were giving reading assignments, so I'll use that as a guide. Treat the topic by topic, and physics, trust me, will be fun. Okay. Will be fun. If you have questions, please do not hesitate to send them to me on WhatsApp, and I'll find time to address it for you. All right. Please tell your friends to be joining, your other colleagues who have registered and colleagues who have not yet registered. Tell them we have started on a very big note, so they should join and they will not regret joining. Okay. I will upload the video. When you get the video, please make time to watch it on YouTube. You can go to the site and you subscribe as well. Okay. All right. So we'll continue our beautiful physics session next week. May the good Lord be with you. Take care of yourself and please spend time to go over this. Okay. Until then, bye-bye.
Thank you, sir.
You're welcome.